and welcome back to our video series on inference. In our last video, we looked at doing a hypothesis test for proportions. And in this video, we'd like to look at hypothesis tests for means. However, it's important to note that we're going to be looking at doing a hypothesis test for means when we have known population standard deviation. And we'd like to return to the problem that we dealt with several videos back, where we were looking at mu, the average commute time to class. And you'll recall several videos back, we looked at calculating a confidence interval for the mean time to commute to class. However, here we're going to look at a hypothesis test. Now, our original belief, our null hypothesis, is that mu is less than or equal to 20. And our alternative belief, what we would like to try to validate, is that the mean time to get to class is greater than 20 minutes. And we're going to set alpha equal to 0.01. Now, you'll recall, we took 3 samples and obtained the following values. Now, we're only going to look at 2 of these. We're not going to do a hypothesis test for all 3. In our first example, let's suppose that our sample mean was x bar is 20.33 minutes. Recall in this example, n was 12. Also recall we had a known population standard deviation value of 7.14054. So when we get to calculating the test statistic in step 3, when we have means that have known population standard deviation values, in other words, we're going to do a hypothesis test for means, but we know the population standard deviation, then we can use z equals x bar minus mu 0 over sigma over the square root of n. That is going to be our test statistic, and it is normally distributed mean 0, standard deviation 1. Here x bar is our sample mean, mu 0 is the value of the null hypothesis, and n is our sample size. We know that we have a sample mean of 20.33. We know the value in our null hypothesis was 20. We know our known standard deviation value is 7.14054. We know our sample size of 12. And what that gives us is a z value of 0.16. And so recall we're doing a greater than test. That means we're looking in the upper tail. So we want probability z is greater than 0.16. That is 1 minus probability z is less than 0.16. And the probability z is less than 0.16 is 0.5636. So 1 minus that gives us a p-value of 0.4364. In this case, we're going to fail to reject the null hypothesis. Our p-value is much greater than 0.01. And so there's insufficient evidence that the mean time to get to class is greater than 20 minutes. What does this mean from a graphical standpoint? Well, again, we have an alternative hypothesis that we believe is greater than 20. So it's an upper tail test, and our alpha was 0.01. And so in order for us to reject our null hypothesis, we'd have to have a p-value that fell below somewhere in this red. That would mean that our p-value would be less than 0.01. However, our p-value was much greater than 0.01, and so we failed to reject the null hypothesis. Now, let's look at a second example. Suppose we wish to test our null belief, our original belief that the mean is greater than or equal to 20, but our alternative is that mean is less than 20. And here we're going to choose alpha equals 0.02. But instead, in this example, let's suppose that our sample mean x bar is 15.67. Again, we still have n equals 12. We still have known population standard deviation. Sigma equals 7.14054. So z is still x bar minus mu 0 over sigma over the square root of n. That gives us 15.67 minus 20 divided by 7.1454 over the square root of 12. And that gives us a z value of negative 2.10. And so we want the probability z is less than negative 2.10. Remember, our alternative hypothesis was that the mean was less than 20. And so we need a lower tail test. Probability z is less than negative 2.10. And that is 0.0178. But recall, our alpha was 0.02. This p-value is smaller than 0.02, and so we will reject the null hypothesis. And in this case, we'll say there is sufficient evidence mean time to get to class is less than 20 minutes. What does this mean graphically? Well, our probability z is less than negative 2.10 is 0.0178. Here, alpha is 0.02. Remember, our alpha is the probability we make a type 1 error. As long as my p-value falls below that probability, I feel safe in rejecting the null hypothesis. Here, p is less than alpha. I will reject the null hypothesis. and say there is sufficient evidence mean time to get to class is less than 20 minutes. Okay, so how might we do this in R? Well, let's take a look. So we'll look at our upper tail test first, our first example. Remember, mu0 is 0, x bar is 20.33, standard deviation for mu0 is 7.14, n was 12. Our z star value, x bar minus mu0 over standard deviation mu0 over square root of n. We can run this. I can then find the probability. Remember, we said that z star was 0.16, and so our probability, here's our z star value, 0.16, 0, 1, lower tail is false. Notice our probability 0.4364. And what, again, might this curve look like? Here's my alpha value of 0.01, but my p-value, 0.4364, my upper tail p-value, is somewhere over here. And so it's much larger than my alpha, and so I'm going to fail to reject the null hypothesis and conclude I've got insufficient evidence to say that the mean time is greater than 20. Now, let's look at our lower tail test. Again, mu0 is still 20. X bar, however, has changed 15.67. Standard deviation is still 7.14. N is still 12. We'll run this so we can get our z star value. And here, our z star value, we said, was negative 2.10. If we look at our p norm, our z star 0, 1, lower tail equal true, we get a p-value of 0.0178. And so what does this look like from a graphical perspective? Well, now, here's our alpha's 0.02. P-value is 0.0178. It is less than alpha. This p-value falls somewhere over in here, and so it's less than alpha. And so this means that there's less of a chance that I'm going to make a mistake in rejecting the hypothesis than I'm willing to risk. And so I'm willing to take the chance. And so I will reject the null hypothesis and conclude that the mean time to get to this class is less than 20 minutes. Okay, that's it for this video. In the next video, we will begin looking at confidence intervals and hypothesis tests for means when we have unknown population standard deviation, and then we'll move on to paired t-tests. See you then.